right, got a little M&M to get us going here. You may be wondering, why so much M&M? Why Slim Shading? Because we're going to be shading some graphs today. Fantastic. We're looking at absolute value graphs. We were solving them algebraically last section. This time we're going to graph them. Excellent. I love this sciences. We're doing absolute value graphs. Let's take a look at this. How hilarious is this? Absolutely nothing next 22 miles. That means there's nothing of value out there. There's nothing for the next 20. Wait, what is that? Oh my goodness. Oh, I can't believe it. Oh, we gotta get out of this. What's next? All right, let's take a look at this. We're gonna graph some absolute value. So I want you to start off with the calculator. So let me show you how to do the first one. If the parent function is like where we start with, it's like the most basic function possible. So the most basic one is the absolute value. The absolute value is the parent function. You know, you can have a square root function, a quadratic, a cubic, all different ones. Let's do absolute value. If you come over here where it says math, hit math, and where's absolute value? It's under number. So you slide over to number, and it's the very first one, ABS. So we're going to do the absolute value of x. So if you zoom standard, get your standard graph, there it is. And we knew that. We looked at that a little bit in the application last time. So there's the graph. So what I want to do is move it up 3. So you can change your y1, or you can come down here to y2. And what are you going to do to this absolute value? And this is just guess and check. I want you to take a minute to play around with this, see if you know it, can figure it out. The first one I'm going to try this. I don't know. Is that right? I'm going to add 3 to it all. Will that move it up? So there was my original. Boom. See how it moved it up 3? So I want you to come over here and be like, okay, sure. To move it up 3, I'm going to take the parent function of this, and what do I do to it? I'm going to add 3 to it. So pause it, see if you can move it down 5, answer this question, answer this question, answer this question, answer that question. Boom, nail it. Good luck. All right, real quick, how did you move it down 5? Well, you took your absolute value. If up is +3, move it down, you're just going to subtract 5. What did this do to it? How did this move it? Aha, it moved it left 2. So interesting. Even though it's a plus sign, it moved it left 2. What did this one do? It moved it right 6. So it's opposite of what you would think. You know, this sign is the opposite way. You know, up and down is normal. That's positive, up, down. But when you're here, that actually moves it left, moves it right. So when it's in the absolute value, if we go left and right, it's opposite of what you think. So if you want to move it right 3, up 5, what did you do? To move it right 3, you know, I'm going to say -3. That'll move it right. And then up is that +5 at the end. Awesome. Hopefully you did that. And if you want to move it left 4, what do? You want to move it left, so it's opposite of what you think. You go +4 and then down 5. So hopefully you were able to do that all in the graphing calculator. See if that worked out for you. Hopefully it did. Cool. All right, let's take a look at reflection. So this whole unit's about the graph, so we can move them up, down, left, and right. There's also reflection. So when you translate it, when you move it, that's called a translation. When you reflect it, it's like looking into a mirror. So let's see what happens here. Here's my parent function, the most basic absolute value. And if I filled in the table, let's just look at the table of values here. If I put -2 in to square root, it's going to make it positive. You know, anything you put in there comes out positive. So that's the basic parent function. So what happens when I put a negative in front? Well, I put -2, absolute value is +2, but then I make it negative again. So what happens? The absolute value makes it positive, but the negative in front makes it negative. Can't have -0. So check this out. So I know in blue, if I graph this, my parent function was the most basic absolute value. So it was that one right there. Maybe yours looks nicer than that. So what does this do? -2, 2. It's the same thing. It's boom. It's like this, isn't it? It's down here. So we could plot all those points. -2, 2, -1, 1, 0. It's a reflection, and we say it's a reflection about the x-axis. So if I ask you to move it left up 3 and flip it, and what do I mean by flip it? Flip it is just, you know, flip it upside down. But really, I mean flip it. I mean this. I mean I want you to reflect it around the x-axis. So how do I do that? What do you think? So I know I can move it left 4. So I want to move it left 4. So I'm going to say +4. I'm going to move it up 3. So I'm going to go +3. And how do I flip it or really make it a reflection on the x-axis? I put a negative in front. So anytime it's negative, it flips it upside down. So that's a reflection. Awesome. Killing it. So what's a transformation? That's when you actually change something about it. So it's not just sliding it or reflecting it. We're actually going to change it a little bit. So again, let's take a look at our parent function. I know when I have my parent function, y equals the absolute value of x. I've got my basic, ooh, that's a little rough right there, but that's my basic absolute value function. What is this 3 in front going to do to it? Well, this is actually called, it's going to change it's going to make it 3 times bigger. So what happens is I know it didn't move it left, right, up, or down, so I know my vertex of it is still here at 0, 0. So again, we have a vertex of absolute value. It's just this point right here. And instead of going, this was going up 1 over 1, up 1 over 1, up 1 over 1 every time, the most basic one. What does this do? This actually is almost like a slope. It goes up 3 over 1. It's 3 times as big, so it goes up 3 over 1. And same thing this way. So it makes it 3 times as steep, so now it made that really steep absolute value. So this is a new thing in front of it. It's going to make it super steep. Awesome. So what do you think 2/5 is going to do? Excellent. It's just like a slope. I didn't move this anywhere, so it's at 0, 0. This goes up 2 over 5. 1, 2, 3, 4, 5 right there. And same thing in the other direction. Up to 1, 2, 3, 4, 5 this way. And this kind of flattened out my absolute value. So we're actually going to change the steepness of the absolute value to a steep one or a flattened one. So that's a transformation. Fantastic, killing it. So is there a general equation for all this? Aha, there is. This is the basic one, and we're going to use this the rest of the year to move it around, to transform it, to translate it, to reflect it. So what does each part mean? So my parent function is the absolute value. Inside the absolute value, this is the h. H and k is like the vertex. So let me come out here and write that. So the vertex, in this case, is h comma k, and it always is h and k. That's like the vertex of it. In this case, it's the absolute value. So the vertex, it's this point right here. So really, we're going to move that vertex around to get these different things. So the h is going to move it left or right. What's the k going to do? It's going to move it up or down. And now we're introducing what I just did the last one. That transformation is actually, in this case, a vertical stretch. I stretched it out vertically. That we're going to call this a. It's the a term. Determines how flat or steep those lines are. So excellent. We're going to use this to graph absolute values by hand. Fantastic. Let's try it. Let's do one together, and then maybe you can pause it and try them yourself here. I've got everything in this one. So I'm looking at this. What I do is first is look for the vertex. Where's the vertex of this one? So you can write it down or just go straight to it. The vertex would be at what? It's 5, comma 2. Remember, it's opposite of what you'd think. It's not left 5 because as you're saying minus that h and k. So it's 5, 2. So if I go right 1, 2, 3, 4, 5, up 1, 2, put a dot. There it is. So that's the vertex. Always find the vertex. And then we do have an a term. This is the steepness. So from there it goes up 2 over 1, up 2 over 1, up 2 over 1. And same in the other direction. So this is my absolute value. Boom. There it is. Nailed it. So that's the absolute value. Can you find the domain and range of this? Sure. What are your x values allowed to be? Well, in this case, it can be, this is going to be all reals. All real numbers, so all real numbers for x, but your range is limited. What's the lowest y possible? Well, it's got to be above, in this case, what? It's got to be greater than or equal to 2. That's the lowest your y can ever get. Awesome. Why don't you pause the next one, see if you can graph this guy over here, and then see if you can write the equation of the one that I have for you. Good luck. Alright, here they are. Hopefully your graph matches my graph here. Remember, the negative flipped it upside down, flipped it over the x-axis, and then you've got this a value of down 2 over 3. Down 2 over 3. Don't forget to fill in the range. Everything is going to be less than 3 in this one. Then I gave you this nice graph here, so you got to count the actual slope of each part of your absolute value. So it should be up 2 over 3. And then don't forget about the vertex. It's at 1, negative 2, so you got to shift it over. And again, your range is everything greater than or equal to 2 or negative 2. Fantastic. Moving on. So we're going to graph inequalities. That was our goal here, is to get to this shady, this whole Slim Shady thing. So let's just do a quick review. Are we okay with doing it for lines? Sure, no problem. If I want to graph a line, I start at 1, and then what do? I go up 2 over 1. So lines, no problem. And there will be a couple of these in your practice, and maybe even on the mastery check. I want to make sure we can graph just linear inequalities as well. Now I got to think, is this dotted or solid? This one is going to be dotted. Why is it dotted? Because of this. It's just less than. It means it can't equal it, so I can't use a solid line. So I got to fill this in with dotted lines. So anything on this dotted line is not a solution. Where are all my solutions? This is less than, and where is less than? Less than is below the line. So everything less than is down here. Fantastic. So shade down there. I'm going to keep shading. There we go. And super. Awesome. How about this? What if I, just a quick rule of inequalities, make sure we got this, is if I want to solve this for y, to graph it, what do I got to do? I got to divide by negative 2, divide everybody by negative 2. But really what's going to happen here when you divide or multiply by negative, it flips the inequality. So I wanted to make sure we're still cool with that. Don't forget about that rule. It flips the inequality. So really this is up at positive 2, and it goes what? Down 3 over 2. Is this solid or dotted? This is a solid line because it has the equal to. It can equal it. So I'm just going to do a straight line through there. Woo! Just like that. And where I'm going to shade, it's greater than, it's above, so I'm going to shade everything above this line. Shade it up. There it is. Fantastic. So how does that relate to absolute values? Well, let's do an absolute value over here. We've got y is less than, so same thing with graphing. What's the shift here? Well, this shifts it right to, the vertex is over 2. It's up or down none, so just shifted it right to, that's it. And then from there, do your a value. So what is a? It's up 3, 1, 2, 3, over 1, 2, 3, 4, put a dot. Same thing the other way, 1, 2, 3, 4, put a dot. Am I solid or dotted? In this case, it has to be less than, it cannot equal it, so I'm a dotted line through there. I'm a dotted line this way through there. Love the dotted line. And where do I shade? Same thing below, so I'm shading everything below the line. Boom, there it is. Oh, I kind of went over a little bit. Don't do that. That's a bad thing. Let me erase that. Fantastic. So that's how we do our inequalities. All right, here are a couple more to try. Why don't you pause it, try these, see how they go, then I'll post the solutions, and we should be good to go. All right, so here we go. The first one, make sure you have a solid line shaded above, moved it left 3, down 1, and it's a negative, so it flipped it, and you got that a of down 2 over 1 every time. Over here, you had to write the inequality here, so it's a greater than or equal to. It's shaded above it, so it's greater than or equal to. It's a solid line. I moved it left 2, up 1, so that take care of that. And then the finale here, I moved it right 3, up 1, so there we go, is the vertex. Then it's going to be upside down, and it does have a slope of 2 over 1. Hopefully that went well for you, and that is it for graphing inequalities. Good luck on the practice and master check. Going to end you here with a guy who breaks more bricks in a minute than I think I probably will in my lifetime. If this doesn't fire you up to do some math, I don't know what will. Good luck on the master check. Peace out.